Alrighty, today we are going to finish off this topic. We're going to finish off our very last topic of the year and be done with pre-calculus, which means that you can move on to legit calculus, which is the best thing ever, obviously. But before we do that, you have to finish this topic. Before you finish this out, you got to finish this last section. So part 6, we're going to continue with the binomial theorem, just finding other ways to find other aspects of things. And if you're writing provincial this year, then you would for sure be able to expect a question like the ones we're going to see today. When we expand and simplify the power of a binomial, we have a whole bunch of unique terms. And because they're unlike terms, they don't have the same variables and exponents combo. Otherwise, it could be simplified further. And we can look at the properties of those terms relating to the exponents on their variables, and we can find which terms have certain properties without having to expand and simplify the whole expression. Now, on one hand, you could actually expand and simplify a whole entire expression just to get the info you're after. And if that's the way you want to do that, that's actually okay. Just note that depending on what it is you're working with, it could take a lot of time. So we're going to learn this method here. If, for example, you wanted the coefficient of x to the 10 in the expansion of this, so now we're assuming that it exists. If the question says it's there, it must be there. The question askers never make mistakes. Just like me, right? I never make mistakes. Ever. If we want to find the coefficient of x to the 10 in the expansion of that particular binomial power, it's going to have this form because every single term has that form. But the thing is, if we just want to find which term actually has x to the 10 at all, then for the time being, we can ignore the coefficients. We can ignore, first of all, this 3 here. That doesn't matter to us in terms of finding just x to the 10. And furthermore, we don't need to worry about n choose k because that has no bearing on the exponent of x. So we ignore those two. And that means in this case, we're looking at this. So we've gotten rid of the n choose k, we've gotten rid of any coefficients we've seen in that binomial, leaving us with this result. And we know that term k plus 1 wants to have x to the 10. So that's what we set up. And at this point, well, we can just solve this equation. We're going to use exponent laws here. So power of a power gives us this. And then multiplying two powers with the same base, we're going to add the exponents. So 14 minus 2k plus k gives us this. And then going back to our exponents and logs units, we know that if two powers are equal and they have the same base, then we can conclude that their exponents must also be equal. So that's what allows us to solve for k in the first place. Note, just as we noted in the previous lesson, just because k is 4 doesn't mean that we're actually talking about term 4. When we plug into this whole formula here, we're talking about term k plus 1. So in this case, if k is 4, then we're talking about term 5. That's not really relevant to this particular example, but just be aware of it, that we're not getting term 4, we are getting term 5. In any case, if we know k, then we can actually plug into this term formula and solve for what we need. So we plug in 4, we know that this will be A, this will be B, and this will be N. So that's where all these values come from. And then it's just simplifying that particular term. Oh, look, that note I said earlier appears right there. Do pay careful attention to what you're actually asked to find. Are you asked to find the coefficient? Are you asked to find the term itself? Are you asked to find which term you're after? Those are all key questions, and you don't want to do irrelevant work, unnecessary work. You don't want to do more work than you have to. You want to be as efficient as you can possibly be. Let's check them out. So in the expansion of 3 over x minus x to the power of 15, which term contains x to the 11? Okay. Well, if we're doing this, we're doing this in purple first of all. Normally, we'd see tk plus 1 is n choose k times a to the n minus k b to the k. So we have that whole formula. But I'm going to ignore parts of it. I know term k plus 1 is going to have x to the 11 in it. I'm going to ignore and choose k. So that's going to be ignored. And then for this a value, I'm not going to plug in 3 over x. I'm actually just going to go with 1 over x. Again, because the numerical values don't matter. That's just a multiplier. Only exponents matter. So that first thing to the a minus k, and the second thing, in fact, don't even need the negative, because that's irrelevant here too. That doesn't change the exponent. All right, that equals x to the k. And now I'm just solving for k. So x to the 11 is, you don't need this particular step, but it might just help with the whole doing the power laws thing. So you don't actually have to write out that it's x to the negative 1, but I'd recommend it just so it's clear as to why this next line is actually negative 15 plus k. X to the 11 is equal to x to the negative 15 plus 2k, using the product of powers law, adding the exponents together. So negative 15 plus k plus this k. And at that point, power equals power. We can say the exponents are equal. And go from there. K is 13. So we're talking about term 13 plus 1. So it's the 14th term. Try out the others, see what you can do. Again, the whole pause this video whenever you want thing applies. I'm going to go ahead. I'm going to look at 1 over x, ignore the 3, to the power of 15 minus k. I'm going to multiply that by x to the k, ignoring the negative. Ta-da. For this next one, we are finding the coefficient of x cubed. You can just straight up expand and multiply this the whole way through. You have that option. My preferred way to do this would be to find which term I'm after and then use that to find the coefficient. So I set this up same. The term I'm after will contain x cubed, and ignoring any coefficients or anything, that means I'm going to have my a, which is just x, because I'm ignoring this 2 for a sec, to the power of 8 minus k, and times 1, because, again, the fact that it's 4 doesn't change any exponents. That's to the power of k. So really what I have here is x cubed is x to the 8 minus k. I'm sorry if my 3 doesn't look like a 3 there. So k is 5. That tells me I'm after the 6th term, if I want to play it that way. I'm going to say I will find that term. So when k is 5, the whole entire term actually looks like this, according to our term formula. Worth noting that the x is not relevant to the coefficient. And if you want to ignore that, you actually can. But the amount of work that's applied by keeping x in there is extremely minimal, so that's not so bad. 8 choose 5 is 56. 2x to the power of 3 is 8x cubed. And then 4 to the power of 5 is 1024. And putting everything together, I get my reference sheet. That number. That is not actually what we're after. We're after just the coefficient. We should stay with the coefficient is so. That. So just make sure your final answer is just fully stated. What is the constant term? If something's constant, that means there's no variable in it. The only way to get that is when your variable's to the power of 0. Our a term, it would be x over 2, but I could probably ignore this over 2 business just to find out which term I'm after. And my b term, negative 4 over x squared. The negative is not relevant, neither is the 4, so really just 1 over x squared. That's what I'll be solving. Product of powers says we're doing this. Two powers of the same base are equal, therefore their coefficients are equal. Whoops. Their exponents are equal. And then finishing that off. Alright, so k is 3. Now it's not asking which term is constant, it's not asking what's the coefficient, it's asking for the term itself. What is the term? What is the constant term? So we're going to find that term. T, 3 plus 1, throw in the formula. We're going to have 9 choose 3. We're going to multiply that by our first term to the power of 9 minus 3, and our second term to the power of 3. Nine choose 3 is 84. X over 2 to the power of 6 is x over 6 over 64, and then negative 4 negative 4 over x squared cubed is negative 64 over x to the 6. And we know we must have done something right, because these x to the 6's are going to cancel each other out, leaving us with a constant. Hooray, huzzah. Also fortunate, these 64's will cancel each other out. In fact, let's use nice colors to slash things. So this will cancel out that, and this will cancel out that, leaving us only with that and that. So the term itself, if you were to expand and simplify that whole power, then the fourth term, the constant term, would just be negative 84. These things take time. These things take a lot of practice. There is some practice work you can do in the textbook, so try those out, but also try out past provincials. Again, this does conclude this topic for us, so I would recommend playing with these. Here's your sample questions from the January 2019 provincial. You can see there's a few terms that have to do, or a few questions that have to do with binomial expansion and stuff we just did yesterday. Play with that. Again, ask me all of the questions you may have, and good luck on whatever final assessments happen. Peace.